Hi, I'm Sunny. And I'm Jean. Today we are going to talk to you about light, atomic models, the quantum mechanical model, electron configurations, and mass spectrometry. First, I'm going to tell you about light. This represents the electromagnetic light spectrum. Remember, I'm going to X your voice in my radio. Gamma waves are the smallest wavelength, but have the greatest frequency, while radio waves are the largest, with the least amount of energy. Here are some good formulas to remember. C equals wavelength times frequency. C is the speed of light, 3 times 10 to the 8th power, in meters per second, wavelength in meters, and frequency in per second. Next we have energy in joules equals H, which is Planck's constant, 6.626 times 10 to the negative 34th joules times seconds, times frequency in per seconds. That's it for you. Now I'm going to talk about the atomic model. There are many different scientists that contributed to this theory. They are pictured above. First is Dalton with his 4 statements. Atoms are tiny particles. Atoms of one element are the same, which proved to be false because of isotopes. Atoms of different elements are different, and compounds form by combining atoms. Second is Thomson. He discovered electrons and proposed the existence of a positive particle. Third is Rutherford. He discovered the proton and called the center of the atom the nucleus through the gold foil experiment. Fourth is Bohr, who proposed that the electrons move around the nucleus in shells, and his model is pictured above. Fifth is Chadwick, who discovered the neutrons that had no charge were found in the nucleus. And last is Millikan, who discovered the charge of a single electron with his oil drop experiment. These are just a few of the many scientists who developed this theory. Next is the quantum mechanical model. It states that it is impossible to know the exact position and speed of an electron at the same time. This is also called the uncertainty principle. There are several quantum numbers used to describe the electron and its orbitals. There's the principal quantum number, which is also known as the periods on the periodic table. There's the orbital quantum number, which describes the shape. There's the magnetic quantum number, which describes the x, y, z, etc. axes of the orbitals. And finally, there's the electron spin, which can be up or down. Now on to electron configurations. There are 4 blocks: the S block, P block, D block, and F block. For the D block and F blocks, you take the principal quantum number, or n, and subtract it by 1 and 2. Below is an example using neon. Neon's electron configuration is 1s2, 2s2, 2p6. Lastly, we have mass spectrometry. This lab technique provides information on molar mass, structure, and abundance of atoms. Behind me is a diagram of a mass spectrometer. First, compounds are fed through the tube and then ionize. The heavier atoms experience less curvature than the lighter atoms, as revealed on the detector at the end. Atoms that appear more frequently on the detector have a greater abundance in the isotope. Here is an example problem involving light with a solution. What is the energy of radiation with a wavelength of 5 times 10 to the negative 3rd meters? First, you would use the speed of light equals the wavelength times the frequency, and you'd solve for the frequency, then plug that into the Planck's constant equation, and finally you would get your energy in joules of 9.9 times 10 to the negative 28th joules. My work is shown below. Thanks for watching. Hope you enjoyed it.